Okay. Okay, let's study the principle of conservation of momentum for explosion. For first situation, we blow a balloon, then release the balloon. So as we can see from this video. Okay. So what happens to the air in the balloon? Okay. So the air move backward. So the air will move backward, and what happened to the balloon? So the balloon will move forward. So what happened? Before the explosion, both the air is inside the balloon are stationary. But when the air is released, the air will move backward, and at the same time the balloon will move forward. So both are moving in opposite direction. So we have another situation. We have a trolley. So the two trolley are put together. So they are stationary. Okay. So before explosion, both trolley are stationary. But after explosion, when we knock the hammer on the trigger, both trolley will move but in opposite direction. That is, A move to the left, B move to the right. Okay, so before both trolley at rest, after both trolley move in opposite direction. Now we look at very detail. So what is the momentum of trolley A before explosion? So 0 because stationary. So the momentum trolley B is 0 also because it is also stationary. So the total momentum trolley A and trolley B before explosion is 0 plus 0, so equals to 0. Now compare the distance D1 and D2. So D1 and D2 will become the same. Okay, D1 here, it will move here to the left. D move to the right with the same distance because both have the same mass. So state relationship between the distance travelled by the trolley and the trolley's velocity. So the longer the distance, the faster the speed. Okay, the longer the distance means the faster the speed. It means that both trolley A and trolley B have the same velocity but they move in opposite direction. So compare the velocity of trolley A and trolley B after explosion. So it will be equal because they have the same distance. Now compare the momentum of trolley A and trolley B after collision. So they will be equal because both have the same mass, therefore both have the same velocity, and the momentum is mv equals, they are both equals. So state the direction of momentum trolley A should be to the right, and momentum B should be the left. So state the total momentum of trolley A and trolley B after the explosion. So both have the same momentum A equals to mv, momentum B equals to minus mv. Minus means opposite direction. Now compare the total momentum before and after explosion. Okay, so the mv plus minus mv, so equals to 0. So again, momentum A equals to mv, because it moved to the left, and momentum B equals to minus mv because it moved to opposite direction. So mv trolley A plus minus mv trolley B, so we get 0. So total momentum after collision equals to 0. Now the question asks compare the total momentum before, so before and after. So before we discussed just now is 0 because both are stationary. So what we have is equal. So as a conclusion, total momentum before 0 equals to total momentum after explosion. So from the what we discussed just now, from the law of conservation of momentum, we have total momentum before explosion or collision equals to total momentum after collision. So for the explosion, we have 0 is equals 0 here on the right, on the left means total momentum before the explosion, when both are at rest. Okay. Now after explosion, what happened? Trolley M1 move to the left, so it has a momentum minus mv1, and so we have the second trolley move to the right, so the momentum is m1 v1. So we have this equation, 0 equals to mv1 plus mv2. So we have minus mv2 equals to minus mv1, means that both have the same momentum but in opposite